Session 4.
In this session, we are going to discuss about cardinal numbers for two sets. Which of them? Two of them are disjoint and two of them are joint. Cardinal number formula for two disjoint sets. Let us consider two sets, that is capital A is equal to 1, 2, 3, and let us consider another one set, capital B is equal to 4, 6. Here, these two sets are very clear. These two sets are disjoint sets. Now we are going to apply cardinal number formula for this. That is, we are going to unite these two sets and we are going to verify the union set number of elements with individual set number of elements. So first let's find A union B. A union B means we have to unite the elements of set A and the elements of set B. So if we unite it, we'll get the answer as 1, 2, 3, 4 and 6. So it is here. So this is our A set, this is our B set, and this is our A union B set. Our topic is about cardinal numbers. What do you mean by cardinal number? Cardinal number is nothing but number of elements in a set is called by the name cardinal number. So we are going to think about cardinal numbers of the set A, set B and set A union B. And we are going to see, is there any relationship between the cardinal number of set A and set B with set A union B. Now let's see A union B, that is 1, 2, 3, 4, 6. Now let's see its cardinality. Number of elements in A set is 3. Number of elements in B sets is 2. And let's see how many elements are in the set A union B, that is 1, 2, 3, 4 and 5. So n of A union B is equal to 5. Right. So number of elements in A set is 3, number of elements in B set is 2 and number of elements in A union B set is 5. Is it possible for us to link the relation, that is it possible for us to link n of A and n of B with n of A union B? Yes, it's very simple. Our result in n of A union B is 5. If we count these two together, we'll get the same answer. So this n of A union B is 5. So we can come to a conclusion, n of A union B is nothing but n of A plus n of B. So it's correct, it works. It works for two disjoint sets. So we have received a formula, n of A union B is equal to n of A plus n of B. Now we have to check, will this formula work for two joint sets? Let us consider again two sets which are joined. Let set A be 1, 2, 3, and let us consider another one set B is equal to 3, 4, 6. So these two are the sets. This is our A set and this is our B set. Now again we are going to find A union B, right? Then what will be your A union B if we unite these two sets? 1, 2, then 3, then we have to write 4 and we have to write 6. We cannot repeat element which is common for both the sets more than once. So our result is 1, 2, 3, 4, 6. This is what our result. So this is our A union B. So our A union B is 1, 2, 3, 4, 6. Now again it is our duty to find, is there any relationship between number of elements in A, number of elements in B with number of elements in A union B. So let's go to the cardinality. That is n of A is nothing but number of elements inside set A, that is 3, and number of elements in set B is also 3. Let's see how many elements are in set A union B, that is 5 elements are in this set. Right. Now already we know a formula, that is n of A union B is equal to n of A plus n of B. It says if you want to find number of elements inside the set A union B, Just you have to count number of elements in set A and number of elements in set B, and you have to add the both. Will it work here? Let us verify. Right. So it gives us the answer as 6. Our n of A union B is equal to 6, because we have the formula n of A union B is equal to n of A plus n of B. 3 plus 3 gives us the answer 6. But in original, our n of A union B is only 5, because we have united these two sets and we have result, and our result is like this. So we received as 5 elements. This is the reality. But here we have 6. So this 5 is correct, the 6 is not correct. Hence, the formula is also not correct. So, the formula which is used for two disjoint sets is not working for two joint sets. First of all, if you think these two sets are disjoint, but the representation is not in the correct way. The real representation should be in this way, like this. So, this is what our A union B. So, now it is our duty to find a formula for n of A union B for the set A and B which are joint. How to do it? We have one formula, that is n of A union B is equal to n of A plus n of B. It is good and it works for two disjoint sets. So if it is possible for us to make a set into a disjoint set, for example this is set A, if it is possible for us to make this set into two sets like this, this 1 2 in a set and 3 in another one set, then this and these two sets are now disjoint if we separate like this. So if it is possible for us to do like this, then we can apply the formula n of A union B is equal to n of A plus n of B. It will work. So let's try to do this. Right, let us consider a set. This is our set A union B. The whole thing is our A union B. This is our A set and this is our B set. As I told you, we have to split them into disjoints. Let us consider only the set A. Just think only this set A. This set can be separated into two sets. This is A difference B and this is A intersection B. So now the set A is divided into two disjoint sets. First set is A difference B and the next set is A intersection B. A difference B means here we'll have some elements which belongs to A but it does not belong to B. Whatever the element here, it is common for A and B. So it is nothing but only A. So whatever the element present here, it will present only in A. It will not in your set B. So this is called by the name only A set. This is called by the name only B set. And this is called by the name A intersection B set, that is common for A and B. So it is just disjointed very easily. Right. So let us try to bring a formula for this. Let us consider this set A. First, just consider this set A alone. If we split this set into two disjoint sets, the first set will be A difference B and the next set will be A intersection B. Both are totally disjoint. So our A difference B and A intersection B makes our set A. So we can write set A as A difference B. This is union A intersection B. Since A difference B and A intersection B, these two sets are disjoint, we can apply the formula n of A union B equal to n of A plus n of B. So if we apply the formula, we'll get the answer as n of A is equal to n of A difference B plus n of A intersection B. If we bring this plus n of A intersection B this side, we'll get the answer as n of A minus n of A intersection B is equal to n of A difference B. So we have a formula now. that is n of a difference b is equal to n of a minus n of a intersection b. Right. How to remember this formula? Very easily. If you want to find n of a difference b, first we have to write this set, that is the set which comes in the front, that is n of a minus n of common to these two sets, that is a intersection b. So n of a difference b is nothing but n of a minus n of a intersection b. If you want to find n of b difference a, we can apply the same logic, that is n of b difference a is nothing but n of b minus common to this, that is b intersection a or a intersection b. So we have received two formula, that is n of a difference b is equal to n of a minus n of a intersection b, and n of b difference a is equal to n of b minus n of a intersection b. Keeping this in mind, let us try to solve sets with joints. Right. Let us again consider two sets. Let the first set be capital A is equal to 1 comma 2 comma 3. Let the next set be 3 comma 4 comma 6. So number of elements in the set A is 3, number of elements in the set B is 3. And let's now try to find A intersection B. If you find A intersection B, the elements which are common for these two sets is 3. So A intersection B is equal to 3. So n of A intersection B, that is number of elements in the set A intersection B, is 1. So this is the originality. Now let's draw this set in Venn diagram. So this is our first disjoint set, that is only A. This is our second disjoint set, only B, and this is common for both the sets, that is A intersection B. So if we split this into three parts, all the three will become disjoint. So this is our only A part, that is A difference B. This is our only B part, that is B difference A, and this is our A intersection B part. So now we have splitted the set A union B into three disjoint sets, that is only A, only B, and A intersection B. So now let's go to the formula. We have to find n of A union B. We have to find n of A union B, total number of elements in A union B set. That can be written as number of elements in A difference B, number of elements in B difference A, then number of elements in A intersection B. Now all these three sets are disjoint sets, so we can add them separately, because if two sets are disjoint, we can apply the formula n of A union B is equal to n of A plus n of B. Like that, since these three are disjoint sets, we can add them separately. Right. Moreover, as we have studied, this n of A difference B can be written as n of A minus n of A intersection B. Use the shortcut. Write the first set as it is, n of A minus common to this set, n of A intersection B. And n of A intersection B is written as it is. For n of B difference A, we have the formula, that is first set, that is n of B minus common to that both, that is B intersection A or A intersection B, that is minus n of A intersection B. Now if you think, these two will be getting cancelled. Now our formula will be n of A union B is equal to n of A plus n of B minus n of A intersection B. So this is what formula for two sets which are joined together. So if two sets are disjoint, we can apply the formula n of A union B is equal to n of A plus n of B. And if two sets are not disjoint, that is if the two sets are joint, we can apply the formula n of A plus n of B minus n of A intersection B. Will it work? Yes. Let's say this. Our n of A is 3. Our n of B is also 3. Our n of A intersection B is 1. Total number of elements is 5. If we count it 1, 2, 3, 4, 5, there are 5 elements we received it. So this is formula for two sets which are joined together. So cardinal number formula for two disjoint sets is n of a union b is equal to n of a plus n of b, and for two joint sets it's n of a union b is equal to n of a plus n of b minus n of a intersection b. Remember these two formulae, and we can practice more problems in the coming classes. Thank you.